We've talked about a lot of trigonometry so far. We've talked about right triangle trig, and we've extended that to other triangles using the laws of sines and cosines. And then we spent a lot of time on the unit circle and sinusoidal graphs and inverse sine and inverse cosine and all that sort of stuff. There's kind of three main areas: triangles, unit circle, and this one, identities and equations. So this is going to be some more analytic, working with trig expressions, trying to make one look like the other, or solving equations involving trigonometry. And we're just going to dip our toe in the water a little bit today to talk about the basic stuff, most of which you already know, and then these very important identities called the Pythagorean identities. Let's start with the difference between an identity and an equation. One of the identities that we're getting ready to learn, one of the Pythagorean, is that sine squared of x plus cosine squared of x equals 1. This is called an identity. This is true no matter what we plug in for x. The identity of the left and the identity of the right are the same. They are the exact same thing. They are equivalent. Sine x equals 1/2. This is only true sometimes. We've been solving little basic equations like this. The sine of what number equals 1/2? Well, that's when the height is 1/2. That's going to happen at 30 degrees. And so on. Identities, always true, no matter what x you plug in. Equations, sometimes true. True for some x's. Now there might be infinitely many x's that we could plug in there, but I can't plug in 31 degrees and get a true statement. I can plug in 30 degrees and get a true statement. I can plug 30 or 31 degrees into this identity on the left, and it will always be 1. All right, so these identities is what we're going to be working with for the majority of this unit. So I'm going to give you a sheet, and it's going to look like this. All of these identities. Beautiful page, full of identities involving trig. And what they're going to do is expand the trig expressions that we can work with. Let's talk about what we know already. This first little section is kind of like the geometry. All right, those are ones, hypotenuse and adjacent. That's like right triangle stuff. That's stuff I'm just going to take for granted that we know about. So I'm going to color those in. All right, this I'm going to keep pulling this screen up from video to video and highlighting it until we've talked about them all and applied them to different types of problems. All right, so let's talk about reciprocals next. Reciprocal means 1 over. Right? When we very first learned what a secant, a cosecant, and a cotangent were, we learned that they were 1 over the sine, cosines, and tangents. And then those could be flip-flopped, of course. So reciprocals, I don't need to say a whole lot about those, but for example, cosecant theta equals 1 over sine theta. All right, that's always true. That's an identity. The cosecant of 48 degrees is the same as 1 over the sine of 48 degrees. Always going to be the case. Don't need to talk a lot about them. Let's go on to quotients. The quotients, you already know those as well. You know that tangent is sine over cosine. You might not think about this one as much, but cotangent is cosine over sine. It's also 1 over tangent, as we just saw a minute ago, but we don't need to spend a whole lot of time talking about those either. All right, tangent x, it doesn't really matter what variable. Don't get caught up on this theta. You know, that's a variable just like x. We usually use x when we start talking about angles and trig. Sometimes we call it theta. Doesn't matter, it's just a variable. Tangent is sine over cosine. Always true, no matter what. Now, we're going to get to the first three good ones. Now, I mentioned this one a second ago. I'm going to go ahead and highlight these because as of today, we know them. Pythagorean. Now think about the unit circle. The unit circle always has a radius of 1, correct? So if you take any angle, let's say 50 degrees, it's about right there, and you take the sine and the cosine, I'll put cosine first because that's x, and where this unit circle is very much connected to right triangle trig with the Pythagorean theorem. If I make my right triangle, the cosine of 50 is down here, the sine of 50 is over here, and because my radius is always 1, if I apply the Pythagorean theorem, x squared plus y squared equals z squared, or ABC, whichever letters, cosine 50 squared plus sine 50 squared must equal 1. And I'm not sure if this has come up yet, but when we want to write cosine 50 squared, let's go ahead and write it all out. If I apply the right triangle, this is true. And that's true if I did 50 or any angle. And it'll be true whichever quadrant I'm in. The cosine of 273 degrees squared plus the sine of 273 squared equals 1. Again, it's an identity. It's always true. But what I was getting ready to say, when we want to write cosine 50 squared, we shorten that by writing cosine squared 50. So we put the square after the cosine or the sine so we do not confuse it with the cosine of 50 squared. Cosine, these two things are the same. The cosine of 50 quantity squared is cosine squared 50. If we wanted to write the cosine of a number squared, there's going to be no parentheses in there, or we would need to write it like this. And that's a little different. But just realize that cosine squared 50 means this. All right, so let's take out the 50 and get our first Pythagorean identity. Here it is in green. Sine squared plus cosine squared equals 1. I'm going to get rid of this specific 50 stuff. Get our first big one. Sine squared x plus cosine squared x equals 1. Because of what I was saying about the unit circle, this is true for any x value you want to plug in. It's an identity. Now, there are two other Pythagorean identities, if you noticed. One of them involves secant squared and tangent squared. The other one involves cosecant squared and cotangent squared. I like to memorize as little as possible and be able to come up with, in a few seconds, as much as possible. So I remember the one with the sine and the cosine. The other ones, if you start trying to remember too much stuff, get confusing. So here's how you can go from one to knowing all three in a matter of a minute. This one we know. We're good with this. Take this equation and on both sides of the equation multiply it by 1 over sine squared. And that needs to apply to all three items in the equation. All I did there was multiply by 1 over sine squared, both sides of the equation. Now simplify that. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. Remember our quotient identities from a minute ago. And 1 over sine squared, remember our reciprocal identities, is 1 over sine squared is cosecant squared. So 1 plus cotangent squared equals cosecant squared. 1 plus cotangent squared equals cosecant squared. So that's how you can get the other one, or the second one. And I bet you can guess how we get the third one. Do the same thing, but with cosine. If we were to take both sides, well, here's the second one. If we were to take both sides and divide them by cosine, we would get tangent squared plus 1 equals secant squared. So I know that tangent and secant go together. Sometimes it's confusing. It's hard to remember where the 1 goes, which side it's on. But if you just remember sine and cosine, you can divide them and get to all three really quickly. All right, so we've just started to work our way through this beautiful, complicated looking page full of trig identities, most of which we knew. These new ones in green we kind of talked about. So what are they for? Who cares? Well, let's look at an example. A typical problem will be to prove that two things are equal, to verify a trig identity. This is a trig identity, all right? This secant over sine minus sine over cosine equals cotangent. That's true, all right? It's hard to really make any sense out of it. I mean, why is this true? Does it matter if it's true? Good questions. But our goal right now is to just verify that it's true. So before we get to analytically verifying that it's true, let's just convince ourselves that it's true. So what I've done here is I've plugged in 22 for A. I'm in radians here, but it doesn't really matter. It works for 22 radians. It also works for 22 degrees. So you can see secant A, I have 1 over cosine 22 divided by sine 22 minus sine 22 over cosine 22. So I just chose a value for A. Let's see what that equals. The left-hand side of this equation equals 112.97. So if this is an identity, which I'm claiming that it is, the other side is cotangent of A. So if that's the truth, then cotangent, which is 1 divided by tangent, is, you guessed it, 112.97. So I just wanted to first convince you that these two things are identical. This is an identity. So now our goal is to confirm it. One of the common things we'll do to confirm it, right? We want to start on the left and end on the right. Start with your more complex looking side. All right, and I'm not sure how much proof you've done, how many proofs. You did a lot of proofs probably in geometry, prove that, you know, these two angles have to be the same or whatever. So we're going to have some similarities to that, but basically a proof is just a confirmation. Just do a bunch of legal steps, don't break any rules, start with one thing and end with the other thing. I want to start with the complex and end with the simple. If I just start with cotangent, it's hard to know where to go. What do I do with it? But if I start with these two fractions, a good thing to start with is going to be, why don't I combine these two fractions? Why don't I add them? So we're going to start forming a little toolbox, a bunch of things to try as we confirm identities. All right, and the first one, a huge one, is to add fractions. And don't forget, if you're going to add two fractions, you need a common denominator. So that's how we're going to pursue this one. The common denominator is going to be sine times cosine. So this first fraction is going to be secant A times cosine A over sine A cosine A. My second fraction is going to be sine A times it's going to be sine A times sine A, right? Because I need a sine A top and bottom. So instead of writing sine A twice, I'm going to write sine squared A. Remember, we just talked about that. And the bottom is sine A cosine A. Okay, so now I'm allowed to add them. I just multiply the one on the left by cosine over cosine, multiply the one on the right by sine over sine. So let's see what happens. The top is secant A cosine A minus sine squared A, common denominator, sine A cosine A. So my big idea of adding fractions I'm done with, and I'm trying to make this thing look like cotangent. All right, so I'm not sure exactly how that's going to happen yet. The thing about the proofs is you don't always see all 5 or 6 steps or however many when you start. You just need to try something, and things will usually take shape. You don't nobody's going to give you a problem that doesn't work out fairly nicely in a reasonable amount of steps. It's not going to be an 88-step proof, so something's going to start happening soon. So look and see what we can simplify. Secant and cosine, there's something there. Secant and cosine are reciprocals of each other. So since secant is 1 over cosine times cosine is 1. Okay? So this is equal to 1 because they're reciprocals. It's just like multiplying 4 by 1/4. Reciprocals make 1. All right, so now 1 minus sine squared. When you see a sine squared, there's a good hint that you're going to use a Pythagorean. And another good hint is those are really the only ones you know at this point. They're not always going to look exactly the same. I might not always be taking out sine squared plus cosine squared and putting in 1, but if I rearrange it a little bit, 1 minus sine squared is, if I take this equation and subtract sine squared from both sides, so you need to always be ready if you see ones and squared trig functions together to use a Pythagorean. So 1 minus sine squared is the same as cosine squared. All right, now I can see it starting to take shape. If I had x squared on top and x on the bottom, I would cancel that and just have x. Same happens with these trig functions. I have 2 cosines on the top, 1 on the bottom, so I'll just leave it as 1 on top, just a sine on the bottom, and what's cosine over sine? Cotangent. What were we trying to show that this left side equals? Cotangent. There we go. We have proven it. That's what it means to confirm or to prove a trig identity. I showed you on the calculator that these two things were equal, and then I showed you using some identities that they're equal symbolically. And I don't want to talk a whole lot more to keep this length down, but we're going to work our way through these. As of now, Pythagoreans are the ones on the table, and we'll get into the rest of this stuff soon. I'm real excited about it. Young out.